Hi, folks. We're going to take a look at number 15 on page 47. So they give us a couple conditions here. They tell us that the limit as x approaches 0 of f at x over x is equal to 1, and limit as x approaches 0 of g of x over x is equal to 2. And then they want us to determine these limits here. So let's take a look at this first one, okay, which is going to be a similar scenario to the second one here. Even though they don't ask us for the limit of f as x approaches 0, we notice that in this expression, the denominator is approaching 0, okay, because x here is approaching 0. Having said that, the limit of this quotient is equal to 1. So essentially what they're telling us is that this limit exists. And what we found is that the only way for a limit to exist where the denominator is approaching 0 is if the numerator is also approaching 0. So essentially what we can say is that the limit of f at x as x approaches 0 has to also be equal to 0. It's the only way for the limit of this quotient to exist. And we've got a very similar scenario here. Okay, we have that the denominator is approaching 0, yet the limit exists. The only way that can happen is if the numerator also approaches 0. Because if the numerator was approaching, say, 2 or 3 or 17, then having the denominator approaching 0 would make this limit not exist. So here we can say that this is equal to 0 since the limit as x approaches 0 of the denominator is equal to 0, which would create an indeterminate form. All right, so just a reminder here that if the numerator of a quotient approaches anything other than 0 when the denominator approaches 0, the limit automatically does not exist. Okay, the only way for such a limit to exist is if both are approaching 0. In other words, if we had an indeterminate form. Okay, so let's take a look now at the second one. They want us to find the limit of f over g. Problem is this is not what we're given. Okay, and even if I use what we just determined, that, well, f at x we said was approaching 0, and g of x is approaching 0, so we do have an indeterminate form, but all that tells us is that the limit may or may not exist. It doesn't tell us what the limit actually is. So it means we have to do some algebra. So that's the conclusion that you have to come to when both numerator and denominator approach 0. The limit may or may not exist. More um, more investigation is required. So the question is how can I take this expression and use the fact that I know these two limits? Well, I know f at x over x, I know g at x over x, so why don't I just divide numerator and denominator by x, which is a legal algebraic operation. So all I'm going to do here is divide f at x by x in the numerator and do the same thing in the denominator. So first of all, we know that this is a legal operation because the fraction will be the same if I multiply or divide by the same number to numerator and denominator. And the fact that I'm dividing by something which is going to create a 0 in the denominator at 0 is not important, because remember, a limit is only interested about what's happening when I'm approaching 0, not what happens when it's equal to 0. But now I know this limit exists based on the information they give me. It's equal to 1. And I know that this limit exists based on the information they give me because it's equal to 2. So that means that I can apply my limit properties and split this up into two different limits. The limits of f at x over x divided by the limit of g of x over x. So I'm applying the limit property for division, and I can do that because I know the limit of the denominator does not approach 0. I know it approaches 2. And so now this limit is equal to 1. This limit here is equal to 2. And there's my final answer. Okay, so let's recap because there's some very important concepts here. Okay, first one is the fact that the only way for the limit of a quotient to exist when the denominator approaches 0 is if the numerator also approaches 0. So since this limit we know exists because it's equal to 2, the only way for that to happen is if the limit of the numerator, g of x, is equal to 0. Okay, and then here I have limit as x approaches 0 of f at x over g of x. So I've already shown that g of x approaches 0, but I made an argument that f at x must also approach 0, meaning that this limit may or may not exist. And so the conclusion is that I have to do a little more work. So here I just use a little algebra trick by dividing both numerator and denominator by x, and I was able to solve for the value of the limit. Okay, that's it for this one.